Hi students and friends, welcome to the channel Learn and Teach by Ayaz. In this video, I'm going to talk about the specimen paper for IGCSE 0620 for the version 2023 and onwards. So I have selected paper 4 today. So let's continue with the video. This is the paper 4 theory, extended one, for examination from 2022-23 and onwards. The duration will be of 1 hour and 15 minutes. So I'm reading the instructions for you. Answer all questions. Use a black or dark blue pen. You may use an HB pencil for any diagrams or graphs. Write your name, center number, and candidate number in the boxes at the top of the page. Write your answer to each question in the space provided. Do not use an erasable pen or correction fluid. Do not write on any barcode codes. You may use a calculator. You should show all your working and use appropriate units. Information. The total mark for this paper is 80. The number of marks for each question or part question is shown in brackets. The priority table is printed in the question paper. So this is the first question. Question number 1. Element X can undergo the following physical changes. These are the physical changes in figure 1.1. Solid X to liquid X, liquid X to gaseous X. The numbers are given 1, 2, 3, 4. A. Number 1. Name each of the numbered physical changes shown in figure 1.1. This is easy one. First is the melting. The melting takes place when solid changes into liquid state. Number 2 is the change from gas to liquid state. So it's condensation or condensing. Number 3 is a change from liquid to solid state, simply freezing. Number 4 is changing from liquid to gas state. You can write boiling. You're also allowed to write evaporation, because evaporation also involves a change of liquid into gas state. Number 2, one difference between boiling and evaporation is the rate at which the processes occur. State one other difference between boiling and evaporation. Remember, evaporation is natural process. Evaporation is natural process. So it happens over a range of temperatures. So you write evaporation happens over a range of temperature. But you need specific temperature in order to boil a liquid. So boiling happens at a specific temperature. B. Describe these separation, arrangement, and motion of particles of element X in the solid state. Now they are talking about the separation, arrangement, and motion of particles in the solid state. Now separation, yeah, they are just touching each other. So you write touching. Arrangement is regular. They are regularly arranged. motion, they are just vibrating about their fixed position. Vibrate about fixed positions. Element X is a group 3 metal. It burns in air to form an oxide X2O3. Write a symbol equation for this reaction. It's very simple. You write the symbol for metal X, and we know oxygen exists in the diatomic state. So you write O2. The complete equation will be X2O3. It's better to balance the equation. If you balance the equation, then you write 3 here, 2 here. So you'll get 4x plus 3O2 gives 2x2O3. Magnesium, calcium, and strontium are group 2 elements. A. Complete table 2.1 to show the electronic configuration of a calcium atom. You should know the proton number of calcium in order to write the electronic configuration. The proton number of calcium is 20. So let's start distributing electrons in each shell. In first shell, the maximum number will be 2. Second, 8. Third, 8. And the fourth one, again 2. If you will add these numbers, you will get 20. B. Describe how the electronic configuration of a strontium atom is. Number 1, similar to the electronic configuration of a calcium atom. Both belongs to group 2, so they have same number of outer electrons. Same number of outer electrons. You can even code the number of electrons also. Next point, different from the electronic configuration of a calcium atom. So it's very easy. If you look at the position of these two elements, look at the position of these two elements. Here you have calcium and this is strontium. So strontium is below calcium. So it's actually in the 5th period. So you write strontium outer electron is in the 5th shell. Outer electron in strontium is in 5th shell. Next question. C. Calcium reacts with cold water to form two products. A colorless gas P, which pops up with a lighted splint. A weakly alkaline solution Q, which turns milky when carbon dioxide is bubbled through it. A. Name gas P. Whenever metal reacts with water, they produce gas. Calcium is one of the reactive gas. So the gas will be hydrogen because this is the only gas which pops up with lighted splint. So you write hydrogen here. Number 2, identify the ion responsible for making solution Q alkaline. So hydroxide or OH negative ion, which is responsible for making solution alkaline, OH negative. Number 3, suggest the pH of solution Q. Now they said it's weakly alkaline. The pH must be above 7 but below 12. So you can write any range between 7 to 10. Number 4, write a symbol equation for the reaction of calcium with cold water. You know the symbol of calcium? Ca, symbol of water, H2O. So you'll get calcium hydroxide plus H2, CaOH whole twice plus H2. Balance the equation, you'll get 2 here. Part D. Magnesium reacts with chlorine to form magnesium chloride, MgCl2. Magnesium chloride is an ionic compound. Number 1, complete the dot and cross diagram in figure 2.1 of the ions in magnesium chloride. Show the charges on the ions. Magnesium is in group 2. The proton number of magnesium is 12. They have already shown 2 electrons, and we know that magnesium, after losing 2 electrons, form Mg plus 2 ion. Mg plus 2. So 2 electrons are lost by magnesium atom. So I'm going to draw the rest of the electrons for magnesium atom, magnesium ion. It is left with 10 electrons. So 2 is already shown. So you'll draw 8 more electrons. 1, 2, 3, 4, 5, 6, 7. Also, you have to mention the charge on the magnesium ion. Chlorine belongs to group 7. And its proton number is 17. 2, 8, 7. It needs 1 electron to complete its valence shell. So both the chlorine atoms have gained 1 electron. So it will become 8. 2, 8, 8. These electrons are shown. So now I'm going to show 8 electrons for each chlorine ions. Remember, you have to show the electrons for chlorine ions with dot. 1, 2, 3, 4, 5, 6, 7. 8th electron is coming from magnesium, so it should be of cross. For this one, 1, 2, 3, 4, 5, 6, 7, 8. So we'll place minus charge on each chlorine or chloride ion. One physical property typical of ionic compounds such as MgCl2 is that they are soluble in water. Give 2 other physical properties that are typical of ionic compounds. Some common properties: they have high melting or boiling point. High melting or boiling point. What else you can write? Good conductor in water, good electrical conductor. In aqueous or water, or when molten. E. Aqueous silver nitrate is added to aqueous magnesium chloride. A white precipitate forms. Write an ionic equation for this reaction. Include state symbols. So the reaction is happening between magnesium chloride and silver nitrate. It's an example of precipitation reaction. The reaction will be AgNO3 plus MgCl2. The product will be AgCl plus MgNO3 whole twice. Now they are asking you to write the ionic equation for this reaction. So if you look at the equation, both AgNO3 and MgCl2 exist in the aqueous state. The only white precipitate is of AgCl, which means it's existing in the solid state. MgNO3 whole twice also existing in the aqueous state. So in the ionic equation, common ions will be cancelled. So NO3 is a common on both sides, Mg also common. So we will be left with these ions in the end. Ag plus aqueous plus 2Cl minus aqueous gives AgCl solid. Question number 3. Copper is a transition element. It has variable oxidation states. A. State two other chemical properties of transition elements which make them different from group 1 elements. Now you have to look for the differences between group 1 and transition metals. So these are the common differences. Transition metals form colored compounds or ions. So you write form colored compounds or ions. Next one, they are used as catalyst. So you write act as catalyst. B, when copper 2 oxide is heated at 800 degrees centigrade, it undergoes the reaction shown by the equation. 4CuO gives 2Cu2O plus O2. Number 1, identify the changes in oxidation numbers of copper and oxygen in this reaction. Explain in terms of changes in oxidation numbers why this is a redox reaction. Change in oxidation number of copper from dash to dash. Change in oxidation number of oxygen from dash to dash. So look at the oxidation number of copper on both sides. On the left hand side, in 4CuO, the oxidation number of copper can be predicted by looking at the valency or charge on oxygen. Oxygen belongs to group 6, so the charge on oxygen is -2 here. So copper must be carrying +2 charge. On the product side, oxygen is present in O2 as well as in Cu2O. So in O2, the charge will be 0 as there is no charge on the element. But in case of Cu2O, again, we look at the group number of oxygen, which is group 6. The change will be -2. So the only change we can see is -2 to 0. So the oxidation number of oxygen is increasing. So you'll write -2 to 0. What about copper? On right hand side, we'll find the oxidation number of copper in Cu2O. Cu2O. We know the charge on oxygen, it's -2, and the overall charge will be 0. There are 2 atoms of copper. I will write 2x. So 2x -2 plus 2 is equal to 0 plus 2. 2 will be cancelled out on the left hand side. So we'll get 2x is equal to plus 2, or x is equal to plus 2 by 2. The answer will be 1. So the change will be +2 to +1. So I'm writing on above Cu. So explanation will be decrease in oxidation numbers. You will write change in terms of decrease and increase in oxidation number. Decrease in oxidation number is reduction. Increase in oxidation number is oxidation. Number 3, calculate the volume of oxygen measured at RTP, which is formed when 1.60 gram of CuO reacts as shown in the equation. This is the equation. 4CuO gives 2Cu2O plus O2. So what we will do, we will convert the mass of CuO into moles in order to get the moles of oxygen. So the MR of CuO will be, we know copper 64 and oxygen 16. So we'll get 80. So the number of moles for CuO will be CuO will be 1.60 divided by 80. You will get 0.02 moles. According to the equation, 4 moles of CuO gives 1 mole O2. Therefore, 0.02 moles gives X moles of oxygen. We'll cross it. You will get X is equal to 0.02 divided by 4. So the answer will be 0.005 moles of oxygen. What you will do, you will simply multiply this value by 24 in order to get the volume of O2. Volume of O2, 24 multiplied by 0.005, and the answer will be 0.12 pm³. Copper metal is obtained when scrap iron is added to aqueous copper 2 sulfate. The reaction between iron and aqueous copper 2 sulfate is a displacement reaction. State why this is displacement reaction takes place. Because iron is more reactive than copper. Iron more reactive than copper. Number 2, write a simple equation for the reaction between iron and aqueous copper 2 sulfate. The symbol for iron is Fe. Copper 2 sulfate, it is CuSO4. Because Cu carries +2 charge, and we know the charge on the radical sulfate, which is -2. Same numbers. So we will ignore the charges. So it will be 2, 2. And these two are same numbers. So we'll get 1, 1. Both will be cancelled. So these subscript will be exchanged. That's why you'll get CuSO4. The product side, you will get FeSO4 plus Cu. A displacement reaction is one method for obtaining copper metal from aqueous copper 2 sulfate. Identify another method for obtaining copper metal from aqueous copper 2 sulfate. It's very easy. Electrolysis. Question number 4. Question is, sulfuric acid has many uses. Sulfuric acid is a strong acid. Define the term acid. Or you have to define in terms of proton. Acids are proton donors. So you write proton donor. Number 2, define the term strong acid. Strong acid completely dissociate in aqueous solution. So you write acid that is completely dissociated in aqueous solution. That completely dissociate in aqueous solution. B. Dilute sulfuric acid is used to make salts known as sulfates. A method consisting of 3 steps is used to make zinc sulfate from zinc carbonate. Step 1. Add an excess of zinc carbonate to 20 cm³ of 0.4 mole per dm³. Dilute sulfuric acid until the reaction is complete. Step 2. Filter the mixture. Step 3. Heat the filtrate until a saturated solution forms and then allow it to crystallize. Number 1, suggest 2 observations which show that the reaction is complete. Step 1. Now they are asking about two observation which shows that the reaction is complete. Now whenever metal carbonate reacts with acid, there will be gas produced known as carbon dioxide. So there must be fizzing. So you'll write no more fizzing. First observation, no more fizzing. Zinc carbonate exists in the solid state. So when the reaction is complete, no more solid dissolves. So you write ZnCO3 stops dissolving. Number two, state why it is important to add an excess of zinc carbonate in step 1 so that it can use all the acid. Define the term saturated solution. Solution which cannot hold any more solute particles. So you have to mention the temperature also, because at higher temperature, saturated solution become super saturated. So you write solution that cannot hold more solute at the specified temperature. Number 4, name another zinc compound which can be used to make zinc sulfate from dilute sulfuric acid using this method. Zinc oxide or zinc hydroxide. Remember, zinc oxide acts as amphoteric oxide. Number 5, suggest why this method would not work to make barium sulfate from barium carbonate and dilute sulfuric acid, because barium sulfate is insoluble. So we need soluble salt. In a titration, a student added 25 centimeter cube of 0.2 mole per dm cube of aqueous sodium hydroxide to a conical flask. The student then added a few drops of methyl orange to the solution in the conical flask. Dilute sulfuric acid is then added from a burette to the conical flask. The volume of dilute sulfuric acid needed to neutralize the aqueous sodium hydroxide was 20 centimeter cube. The reaction is shown by the equation. 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Number 1, state the color of methyl orange in aqueous sodium hydroxide. Sodium hydroxide is alkali. So in alkali, methyl orange shows yellow color or gives yellow color. Number 2, determine the concentration of the dilute sulfuric acid in gram decimeter cube per decimeter cube using the following steps. Calculate the number of moles of aqueous sodium hydroxide added to the conical flask. So we know the strength of sodium hydroxide, it's 0.2 mole per dm cube. 0.2 mole per dm cube, and the volume is 25 centimeter cube. So you write 1000 centimeter cube, because we know 1 dm cube is equal to 1000 centimeter cube. 1000 centimeter cube contains 0.2 moles. Therefore, 25 centimeter cube contains X moles. So X will be 0.2 multiplied by 25 divided by 1000. So the answer will be 0.005 moles of sodium hydroxide. Calculate the number of moles of dilute sulfuric acid added from the burette. Now you'll write the reaction equation here. Here's the equation. NaOH, 2NaOH plus H2SO4. We know the number of moles of sulfuric acid is 1 and sodium hydroxide is 2. So what you will do, you will calculate the number of moles of sulfuric acid. 0.005 moles of sodium hydroxide reacts with X moles of H2SO4. So X will be equal to 0.005 divided by 2. The answer will be 0.0025. 5 moles of sulfuric acid. Calculate the concentration of dilute sulfuric acid in mole per dm cube. Now these are the moles which are present in 20 centimeter cube of sulfuric acid, which are initially used in this reaction. See, 20 centimeter cube of sulfuric acid is sulfuric acid. This is the volume for sulfuric acid. So you write 20 centimeter cube contains 0.0025 moles. Therefore, 1000 centimeter cube contains X moles. So it will be X is equal to 0.0025 multiplied by 1000 and divided by 20. So the answer will be 0.125 mole per dm cube. Now you got the moles of sulfuric acid. They are asking that you to calculate the concentration of dilute sulfuric acid in gram per decimeter cube. Simply you will convert moles into grams. Moles into grams. You know the formula? Mass is equal to number of moles multiplied by MR. Now we have sulfuric acid. The MR of sulfuric acid will be 98. So you'll multiply this by 0.125. Answer will be 12.25 grams per decimeter cube. This will be your final answer. Number 5. Student investigates the progress of the reaction between dilute hydrochloric acid HCl and an excess of large pieces of marble CaCO3 using the apparatus shown in figure 5.1. This is the figure. You can see dilute hydrochloric acid. You have an excess of large pieces of marble. This is gas syringe. A graph of the volume of gas produced against time is shown in figure 5.2. This is a graph. On x-axis, you have time. On y-axis, volume of gas produced, which is in centimeter cube. Number 1, state how the shape of the graph shows the rate of reaction decreases as the reaction progresses. You see the gradient decreases. This is a gradient. This decreases. So you write gradient decreases. Suggest why the rate of reaction decreases as the reaction progresses. It's very simple. Concentration of HCl is decreasing. Concentration of HCl is decreasing. Because if you look at the question, CaCO3, which is marble, it is in excess. So HCl is the limiting. It's just limiting here. So the gas produced will be depending on the limiting reactant here. So that's why concentration of HCl is decreasing. Number 3, deduce the time at which the reaction finishes. You look at the time by looking at the graph. Find the time. It will be 200 seconds. 200 seconds. The experiment is repeated using the same mass of smaller pieces of marble. All other conditions are kept the same. Draw a line on the grid in figure 5.2 to show the progress of the reaction using the smaller pieces of marble. Now they are just saying they have used smaller pieces of marble instead of large piece. So what will happen to the graph? The reaction will be acting fast here. So you will have new line which will be steeper than the printed line. And it means that it levels before 200 seconds. And starting point will be same. It will be like this. C. The original experiment is repeated at a higher temperature. All other conditions are kept the same. The resulting increase in rate of reaction can be explained in terms of activation energy and collisions between particles. Define the term activation energy. It's the minimum energy required to activate the reacting particles. So you can write minimum energy, minimum amount of energy that colliding particles must have. Number 3, explain why the rate of a reaction increases when temperature increases in terms of activation energy and collisions between particles. They are saying that the rate of reaction increases when temperature increases. What is happening? The particles having more energy. So they will start moving faster. There will be more frequent collisions. So the particles have energy greater than the activation energy. So this is 3 marks question. So first of all, you will write particles have more energy. Particles have more energy and so move faster. So next point, more frequent collisions. More frequent collisions. It's very important. You have to write between particles. So because the collision can be with the walls of the container. So that you can say particles have energy greater than the activation energy. Particles have energy greater than the EA or activation energy. Number 6, alkynes and alkenes are homologous series of unsaturated hydrocarbons. All alkynes contain a C triple C or triple bond. A. Complete table 6.1 showing information about the first 3 alkynes. Table 6.1, the formula, structure and names given. First one is ethyne. This is ethyne. They are asking about the name for the second member. The third member is butane. Recall the names for alkanes. If you know the value of N, 1, 2, 3, 4. We have methane. So you'll write meth. Ethane, so you have eth. Propanes, you have prop. Fourth one, bute. They have already mentioned eth and prop bute. So you have prop. So the name is ending on "ine." Name ending on "ine." So the name will be easy: propine. Propine. P. Compounds in the same homologous series have the same general formula. Give two other characteristics of members of a homologous series. You can write any of these. Contain same functional group. Differ one member. Each member by CH2 unit, or there is a trend in physical properties, similar chemical properties, same method of preparation. So contain same functional group, trend in physical properties, same chemical properties, same method of preparation, or successive member differs by CH2 group or 14 units. Number 2, deduce the general formula of alkynes. Use the information from table 6.1 to help you. Now they are asking you to deduce a general formula for alkynes. Let's write the molecular formula for each member. So we have ethyne, propine, but, 1, ine. Look at the formula, it's C2H2. Next member, C3H4. Here's the formula. The third member, it's C4H6. Now, in each step, we know the general formula for alkane, which is CnH2n plus 2. This is alkane. And alkene, it's CnH2n. But you see, they are decreasing the each molecule. They're decreasing. There's decrease of 2 hydrogen atoms. So you can add for alkyne. It must be alkyne. It must be CnH2n minus 2. You can apply it. You'll get the formula. These formulas. So you'll write CnH2n minus 2. Alkynes are unsaturated. Describe a test for unsaturation. You have only one test for unsaturated organic molecules. Bromine, water, aqueous bromine. Bromine, water. We can write aqueous bromine, decolorize. Simply decolorizes. Number C, ethene and but2ine are alkenes. Draw the displayed formula of but2ene. They're asking about you to draw the displayed formula for butene. You know the formula for butene. If you know the value of N, it should be 4. It's alkene. So you know the general formula, CnH2n. Putting these values, you will get C4H8. So there must be 4 carbon atoms. 1, 2, 3, 4. It's an unsaturated. There must be 1 carbon-carbon double bond. So I'm placing double bond between these 2 carbon atoms. Well, let's place hydrogen atoms. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this will be your final general displayed formula for but2ene. Number 2, draw a dot and cross diagram to show a molecule of ethene, CH2. Show outer shell electrons only. So I'm using the dot and cross here. So you have C here, H here. For C, I'm using dot. Hydrogen, I'm using cross. Should be like this. 2C and 4H. Now showing the electrons between each atom. Between two carbon atoms, there must be two pairs of 4 electrons. 1, 2, 3, 4. For this carbon, 1, 2. For this one, 1, 2. So all the 4 electrons for each carbon atoms are placed. Now let's place the valence electrons for each hydrogen atom. One for this one for this one for this one, and one for this one. So this will be the final dot and cross diagram for alkene. Ethene can be converted to ethanoic acid by 2-stage processes. In stage 1, ethene is converted to ethanol by catalytic addition. This is C2H4 plus H2O. You are getting C2H5OH. You are getting only one product. Number 1, suggest why stage 1 is called an addition reaction. Simple answer, one product form. Number 2, a catalyst is used in stage 1. Stage 1, other conditions that must be used here. So there are some conditions for this one. You can quote pressure or temperature, and steam is also used here. So you can write any of these, anyone, steam or temperature, 100 degrees centigrade, above 100 degrees centigrade, or pressure, quote pressure 20 to 100 atm. State what must be reacted with ethanol to form ethanoic acid. It's an oxidation reaction, so you have oxidizing agent, acidified aqueous potassium magnate. Acidified aqueous potassium manganate. Seven. This is the last question. 7. Carboxylic acids can be converted into esters. A, propanoic acid and methanol react to form an ester that has the molecular formula C4H8O2. Name this ester and draw the displayed formula. Name of the ester, displayed formula. How you're going to name the ester? Remember, whenever alcohol reacts with carboxylic acid, ester is formed. Alkyl group is coming from alcohol. Alcohol, we get alkyl group. In this case, you are getting methyl and carboxylic acid. You will get alkanoate. So propanoic acid, you will get propanoate. Propanoate. Name of ester will be methyl propanoate. Displayed formula. Now it's up to you. If you want to start with methyl, you can start in this way. Now propanoate will be starting from this side. So you'll start with O. We have C, double bond O. 1, 2, 3. This is propanoate. Now I'm placing hydrogen atoms. This is methyl propanoate. Alternatively, you can draw this in this way also. 1, 2, 3. O, C, H3. Number 2, name another ester with the molecular formula C4H8O2. You can have any ester with this molecular formula. For example, in this case, you can have propyl methanoate. Remember, the total carbon atom should be 4. So you can have ethyl ethanoate. Number B, polyesters are polymers made from dicarboxylic acids. Name the other type of organic compound used in the formation of polyesters. Diol. Number 2, name the type of polymerization used in the manufacturing of polyesters. Simply condensation. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.